Flavio Villanustre. I work for LexisNexis Resolutions. I presented a keynote today on the convergence of HPC and data-intensive computing. The interesting areas in this convergence happen to be on the one side, learning the lessons that HPC brought to us over the last 10 or 15 years, and the new lessons that we learned from data-intensive computing. So we went through data locality and how important that is for efficient data-intensive computing, but we also went through some of the models that HPC has for programming environments and for type of hardware architectures to leverage those type of models for data-intensive computing. We also explored the need for higher level user interfaces and abstractions, programming abstractions for the future development in this convergence. And the fact that we need to remove some of the burden on the parallelism from the programmers and put it in the tools, so the tools can build more efficient code by just knowing what the programmer needs and wants to do. The interesting things about the future, and there are quite a few of these, are new developments in hardware architectures. We have now the ability to do in-memory computing using very specialized processors in memory. We have also the ability to move some of the filtering functionality into the storage unit, so in your SSDs or your flash. So this gives you the ability to transfer exactly the data that you need from these storage units rather than everything contained in that block or in that sector. And ultimately, again, we explore some of the higher level declarative user interfaces and programming models, which are key for the global adoption of this type of environments. LexisNexis Resolutions is a data services provider. We provide data analytics services to corporations. Our biggest market is the US market. We are now penetrating other markets outside of the US, like the UK market and India and China. And we've been doing this for 15 or 18 years. And our data has always been large. And at some point, this large data, this complex data, and this sophisticated type of algorithms became big data. So we transitioned into it. Now, back in the late 90s, we built our own high-performance computing platform called HPCC. And we use that platform to support and serve every one of our products. This provides for all the back-end data manipulation, all the heavy lifting on the batch-oriented model, plus all the real-time delivery models. And recently we open sourced the project. We released it in 2011 as an open source project for everyone to use. So we are trying now to gather more adoption around the community, and this brings a lot of innovation to our software as well, which is what we really capitalize from this effort.
Okay. Thank you very much.
Thank you.